Hi, my name is Kata Baverlick, and I am the Program Manager for Watershed Plans and Analytics at Credit Valley Conservation. I oversee the development of CVC's new Watershed Plan, and today I'll be sharing the results from our Characterization Report. In this presentation, I'll provide some context by describing what a watershed is, what a conservation authority is, and what our core programs are according to the new Conservation Authorities Act. Then I'll briefly describe the watershed planning process and how the results from the plan can be used to guide the work we collectively do in the watershed. I'll then jump into sharing some of the stories coming out of the first phase of work, as well as some of the tools that can help in watershed planning moving forward. A watershed is the entire area of land that drains its rain or snowmelt into a body of water such as a river or lake. The boundaries of a watershed are determined by the landscape and elevation surrounding that body of water. In the case of the Credit River Watershed, this includes the Credit River and Lake Ontario tributaries. Our watershed stretches from Orangeville in the north all the way down to Mississauga, where the Credit River connects to Lake Ontario. The northern regions of the watershed are mostly rural, characterized by a mix of natural and agricultural cover. Here we have parts of the Greenbelt, Niagara Escarpment, and Oak Ridges Moraine. These are the provincial scale plans that protect important natural features across the province. The lower part of the watershed is mostly urban and urbanizing, and includes the cities of Mississauga and Brampton. When I talk about the health of the watershed, I'm referring to the condition of our natural heritage and water resource systems. This includes the forests, wetlands, streams, and groundwater within the watershed boundary that you see on the slide. Credit Valley Conservation is a community-based environmental organization dedicated to protecting, restoring, and managing the natural resources of the Credit River Watershed. Established by the provincial government in the 1950s, CVC is one of 36 conservation authorities in Ontario. As a scientific agency, we support municipalities and provincial programs as defined by the Conservation Authorities Act, with a focus on natural hazard management, management of conservation authority-owned lands, drinking water source protection, and surface water and groundwater monitoring programs. In addition to the work that is provincially mandated, municipalities do fund other projects that support their specific needs. To achieve our core responsibilities, we work in partnership with municipal governments, landowners, community organizations, schools, and businesses to deliver locally based programs. A watershed plan is a document that is driven by a defined process. Here, I will spend a little time explaining what a watershed plan is and how the information in this plan is used by many stakeholders. When making decisions about land cover, land use, and growth, we need an approach that addresses the many stressors and impacts in the watershed. Watershed planning provides a process that helps us develop long-term strategic recommendations for the protection and enhancement of watershed health that is based on best available science. A watershed plan is an essential tool to help answer two important questions. Where do we need to go, and how do we get there? Watershed plans are inherently interdisciplinary. We draw on science from many disciplines informed by demographics and culture to build an understanding of how the watershed and its systems work, how they may be affected by change in the future, and how our collective actions can either exacerbate or mitigate those impacts. CVC's first watershed plan was completed in 1956. The new watershed plan will allow us to take into account the latest science and data, as well as stakeholder and community input, to establish long-term priorities for CVC and municipal partners, setting the stage for CVC's scope of work for years to come. The new plan will incorporate many of the plans and strategies we have developed in recent years, with guidance from provincial policies and municipal documents. Ultimately, we integrate all of these important products and fill some of the existing gaps in a strategic way. It is this multidisciplinary and integrative aspect that make the Watershed Plan useful to so many stakeholders. For example, the plan will support municipalities by informing things like stormwater management criteria and natural asset management. For watershed residents, the plan can identify where on private and publicly owned property invasive species management is needed, or where enhanced agricultural best management practices are beneficial. And CVC will use the information to update products such as hazard maps or prioritize restoration opportunities. Importantly, all of this is closely tied to CVC's new strategic plan. Watershed plans are developed following 3 phases. I'll explain what those are and where we are in the process. In phase 1, the characterization phase, we tell the story of the health of the watershed and how it has changed from the 1950s to the present. I'll be sharing the results from our characterization report today. Phase 2 is the scenario modeling and impact assessment stage. We look into the future to 2051 and we project how the health of the watershed may be affected by changing climate and land use, as well as the other actions we take. We're currently in the modeling stage with anticipated completion next year. Finally, phase 3 involves the development of a watershed plan. Based on what we learn in phases 1 and 2, we select a preferred management scenario and develop a blueprint to protect and enhance the long-term health of the watershed. This will be started once the results from phase 2 are complete. Before I get into some of the results from the characterization report, I want to provide an overview of just how much content it includes. We have 19 body chapters with approximately 600 written pages. The report also includes almost 100 maps and over 106 figures. The chapters are split into 4 main parts that represent the major themes of the report. This includes the human dimension, study area and physical setting, water resources, and natural heritage. This characterization report is a nice package that provides a rich overview of watershed conditions, but also shares the many tools and maps that can help to really target and prioritize on-the-ground action. By sharing the information together, I hope you will get a good handle on some of our biggest concerns, as well as how we're working towards improving conditions today and where we may go in the future collectively. These results will include statistics, but also many maps. This will help you understand how things are looking in your local area, which can then drive meaningful change. I want to emphasize that today I will just be touching on some of the results, but cannot do justice to the report in a short presentation. Please keep in mind that many of the findings in the characterization report are based on data and analyses that come from CVC's long-term monitoring program. Initiated in 1999, this program allows us to characterize watershed health today and describe the changes we've seen over time. To complement the information collected by CVC, we also use data from long-term provincial and federally monitoring programs to describe trends in climate, water chemistry, and stream flow. Some of these data sets go all the way back to the 1930s. So, first I'll share some results about natural cover and land use. As part of CVC's Natural Heritage System strategy, a series of targets were selected for natural cover. These targets are intended to support objectives related to water quality and quantity while improving the function and resilience of watershed ecosystems and biodiversity. Natural cover provides vital ecosystem services that reduce the impacts of natural hazards such as flooding, as well as sequester carbon and filter water. Currently, the watershed falls below most targets. The only target met was the number of large woodlands. This means that in some areas, not only is the amount of natural cover too low, but the remaining features are isolated and exposed to stressors surrounding them. Although we're not reaching many of the natural cover targets, on average, we're meeting green space targets that have been recommended by the World Health Organization. These green spaces include parks, open spaces, public lands, and institutional lands that are accessible to the public. In this map, you see where these green spaces are, including CVC properties, public parks, and trails. These are shaded in yellow, green, and pink. They support the mental and physical well-being of watershed residents and visitors, providing space to connect to nature, exercise, and explore. Some of these green spaces also provide those vital ecosystem services I mentioned earlier. We know that one way to achieve our natural cover targets is to restore habitat. I'll provide some more details on that a little later in this presentation. However, in addition to restoration, we also need to help wildlife move from one habitat patch to another in a landscape that has many roads and barriers. In the Watershed Plan, we have maps that identify bridges and culverts that are impassable by fish and wildlife species. Municipalities can use this information when they are making upgrades to roads to ensure they make these more passable for wildlife. Now I'll move into discussing some of the trends in climate. Based on an analysis of air temperature and precipitation trends at Pearson and Orangeville, we're seeing warmer and wetter conditions. Since 1938, average temperatures at Pearson have increased by 1.8 degrees Celsius. Of note, winter is warming faster than other seasons, and we are seeing more pronounced warming in the nighttime lows. Although most temperature metrics show warming trends, there are two I thought would be of particular interest. The growing season, measured by number of days in a row that air temperature was above freezing, is about 40 days longer than it was 80 years ago, so there may be opportunities to extend the growing season for some crops. However, cooling degree days, which refers to the number of days in a year air conditioning units will be on, have increased by 14 days over the same period, so this could mean higher cooling costs throughout the year. Similar to most of the other temperature metrics, this increase has occurred mostly in the period from 1980 onwards. In the Watershed Plan, we've created some novel products that can help prioritize climate action. For example, we've used satellite images to show how warm the ground surface is in the summertime. The lowest temperatures are blue in this map, with the color changing from yellow to orange to red as temperatures increase. In areas of the watershed that are red, the surface temperature is above 30 degrees Celsius, compared to blue areas that are around 17 degrees. As you can see, urban areas are much warmer than rural areas. Trees are one way we can cool surface temperatures, so this map can help identify where urban tree plantings may be especially valuable to protect residents from heat exhaustion. This information can guide decisions on where the next sustainable neighborhood action plans will go, such as the one we have in the Fletchers Creek area of Brampton. Through CVC's monitoring program, we've been able to track the response of both living and non-living indicators to warming conditions. Since 1999, stream water temperatures across the watershed have been warming. We're seeing more days where the water temperature is higher than what the cold water fish species like brook trout are adapted to. Populations of invasive pests that kill trees, such as emerald ash borer and beech scale, are able to thrive with warmer winter conditions. Most of our beech trees are showing signs of infection, and over half of all ash trees are declining due to emerald ash borer. As some of the most common tree species in our woodlands, this can have some serious impacts on woodland health throughout the watershed. Finally, species from more southern regions of the province are now spreading northwards throughout the watershed, taking advantage of warming conditions. This includes the red-bellied woodpecker that has increased by 65% since 2002, but also less desirable species like ticks that can spread Lyme disease. For the Watershed Plan, we've used our monitoring data to identify where stream temperatures diverge the most from what they're supposed to be based on the province's aquatic ecosystem classification. In this map, that dots that are a different color than the underlying stream indicate that the location is likely warmer than it should be. This information can be used to identify areas that may need some extra streamside plantings, dam mitigation, or other restoration to cool water temperatures. Here's an example of some riparian plantings we did along a tributary of the West Credit River in Hillsburg. A project like this can help to keep streams cooler, reduce bank erosion, and stop sediment-bound pollutants from entering the water. And once you plant up those riparian areas, the wildlife are bound to take advantage of the newly available habitat. The information we pull together in the Watershed Plan can help identify and prioritize where these types of projects are essential to mitigate the impacts of climate change. There are many results worth mentioning related to water quality and quantity. Water quality in streams is marginal overall. This marginal water quality is heavily driven by two parameters. Chloride concentrations are increasing at 74% of our monitoring stations and exceed guidelines to protect aquatic life at almost half of them. Increasing chlorides are attributed mostly to increasing application of road salts on paved surfaces such as roads, driveways, sidewalks, and parking lots. In this map, you can see where chloride concentrations are increasing, noted by triangles pointing up, and where concentrations are exceeding guidelines, shown as red symbols. Knowing where in the watershed we have chloride issues highlights where management of road salt application by municipalities, businesses, and private landowners is necessary. The other parameter that contributes to marginal water quality is total phosphorus. The story about total phosphorus is a bit more complicated than it is for chlorides. Similar to province-wide trends, total phosphorus concentrations in the watershed have been decreasing. These decreases have been attributed to legislation in the 1970s that mandated the reduction of phosphorus from wastewater treatment plant effluent and prompted the removal of phosphates from detergents. However, despite these decreases, concentrations at 78% of the monitoring stations are still above guidelines. High total phosphorus concentrations are results of both urban and agricultural land uses. Sources of phosphates in the watershed include runoff that contains fertilizers and sediment from soil erosion. Although phosphorus is important for plant growth, too much can cause excessive algae growth in streams. Algal blooms can deplete oxygen levels, which makes streams less suitable for aquatic wildlife such as fish. The picture you see here is an algal bloom in the Credit River this summer. These blooms can also clog up drinking water intake pipes. This happened in the spring of 2012, where the region of Peel's Lauren Water Treatment Park plant was damaged when significant algae growth clogged the intake from Lake Ontario. This damage temporarily reduced the output capacity of the water treatment plant and resulted in unexpected costs for the region of Peel. This is especially relevant to residents who live in the cities of Brampton and Mississauga, who get their drinking water from Lake Ontario. Knowing where in the watershed total phosphorus exceeds guidelines helps us understand how to focus outreach and education programming related to best management practices to reduce nutrient pollution. In addition to stream chemistry and temperature, we've also seen some trends in the stream flows. For example, out of the 12 stream flow stations we analyzed, 5 had increasing average flows by as much as 40%. 5 stations also had an increase in low flows by up to 72%. These increasing flows can be attributed to things such as increased discharge of water from wastewater treatment plants, as well as high percent impervious cover associated with urban development. One way that we can address some of the issues with water pollution and flooding potential in urban areas is by dealing with stormwater. Stormwater is the water that runs off the land after a rain or snow event and eventually to our wetlands, rivers, streams, and lakes. Stormwater management takes excess runoff away from buildings and other built features to make communities resilient to flooding. Stormwater ponds are one type of stormwater management approach that many municipalities have used over the years. In some neighborhoods, these ponds can be accessed by a series of trails and provide wildlife viewing opportunities. This map shows where in the watershed we're likely to have stormwater control based on the age of development. Communities that were built before the 1980s don't generally have any stormwater controls like stormwater ponds. Those are shaded red in this map. Communities that were built between 1980 and 1995 may have water quantity controls. Those are shaded orange. And then communities that were built after 1995 may have a combination of water quantity and quality controls. Those are shaded in gray. Keep in mind that the green areas are natural cover, so stormwater control in these areas is provided by the wetlands, streams, and forests on the landscape. By combining this map with information on where we see issues with water quality and sensitive aquatic ecosystems, we can recommend where stormwater management practices are most needed. One way to do that is by putting in low-impact development features like rain gardens. CVC has worked with private and municipal partners to install low-impact development projects that have serviced over 127 hectares of land since 2007. Groundwater quality and quantity also require your attention. Similar to streams, we've seen increasing chloride and sodium concentrations at our groundwater wells and guideline exceedances at over 1/4 of them. High chloride concentrations in groundwater is a concern because many residents who live outside of Brampton and Mississauga get their drinking water from groundwater. Elevated concentrations of chloride and sodium in groundwater can negatively impact people by changing the taste of drinking water or damaging household plumbing through the corrosion of metal pipes. Elevated sodium concentrations are also a concern for people who need to limit sodium in their diets. High chloride concentrations in groundwater can also lead to an increase in chloride concentrations in streams and rivers that harm aquatic plants and animals. Groundwater levels have also shown changes over the monitoring period, with 25% of our wells showing decreasing levels and 42% showing increasing levels between 2003 and 2016. In the watershed, municipal water taking for drinking water is one of the biggest pressures on water levels. However, land use change can also influence recharge patterns and impact how water makes it into the ground. High groundwater levels can increase the risk of basement flooding. Decreases in groundwater levels can reduce water available for drinking and irrigation, and also stress ecosystems that rely on groundwater inputs such as wetlands and cold water streams. In combination with information from the municipal groundwater wells and by working with source water protection, these data can be used to focus outreach, education, and mitigation efforts. This is a core part of the work that CVC does. Our data also indicate that there are pressures on biodiversity. As the canopy was opening up due to beach bark disease and emerald ash borer, this has provided an opportunity for species to take advantage of these new conditions. Both non-native and disturbance-tolerant plant species have become more abundant throughout the watershed over the monitoring period. This includes species like garlic mustard and European buckthorn. 5 forest bird species have experienced population declines since monitoring began in 2002. This includes a ground nesting species, the ovenbird, a species at risk, the wood thrush, keystone cavity provider, the northern flicker, and common species, American goldfinch and common grackle. The fact that we're seeing declines in both common and rare species is concerning. We've included a map showing which of our inventoried woodland communities have at least one invasive plant species. As you can see, 90% of inventoried woodlands in the watershed Have at least one invasive plant species shaded in orange or red. This can help to guide where invasive species management occurs in partnership with local residents, municipalities, and businesses. Because invasive species are everywhere, we all have to work together to make a difference. Many invasive pests and diseases target some of our most common tree species. We've also used our inventory data to identify which woodlands are vulnerable to existing or emerging forest pests that target ash, American beech, hemlock, and oak trees. Based on this analysis, the amount of vulnerable woodlands in some municipalities is up to 46%. These pests and diseases cause trees to die, opening up the canopy so that more invasive species can move in. So it's important for landowners and managers to know whether their properties are vulnerable in the short term. Pressures on biodiversity have also been observed in our wetlands and streams. Warm weather conditions and changes to precipitation patterns across the watershed may be linked to the emergence and spread of diseases in animals. Ranavirus outbreaks causing mass mortality in frog and fish populations occurred in one known location in the watershed in 2019 and 2020. Since 1999, the biomass of brook trout, a cold water species, has decreased by up to 65%, and the biomass of all fish species combined has also decreased. Benthic macroinvertebrates have also shown some issues with declining species diversity, as well as compromised health at half of our stations. Based on our monitoring data, we've been able to evaluate the health of forests, wetlands, and streams. Not surprisingly, these ecosystems are healthier in the upper parts of the watershed. Larger and connected natural features and landscapes with higher natural cover lead to healthier ecosystems. Forest communities are fair quality overall based on the health of the tree, plant, and bird communities. Stream communities are also fair quality based on water chemistry, temperature, bank stability, fish, and aquatic bug communities. And of the wetlands that do remain on the landscape, they are good quality overall based on plant and frog communities. Many of our monitoring and inventory sites are on municipal and private lands, so although the regional trends are insightful, some of the site level information will help prioritize where to manage, enhance, and restore, as well as what actions would be of the most value. So I know that all sounds very discouraging, but we've also seen examples of a resilient watershed. Forest communities throughout the watershed continue to support a rich diversity of plant and bird species. For example, even though we have seen an increase in spongy moth and fall cankerworm over the last 10 years, we are not seeing sustained signs of canopy stress in our forests due to these insects. Our monitored wetland communities continue to have a high integrity and support many plant and frog species. Even urban wetlands provide habitat for 8 of the 10 frog species known to occur in the watershed. We are also seeing populations of wildlife bouncing back following the removal of certain stressors. American crow populations have rebounded from West Nile virus, and the increase of dead trees has resulted in more woodpeckers in our forests. Both the aquatic insect community and brook trout populations have rebounded once the water chemistry conditions improved at certain sites. Although not all of these successes are related to our specific actions, it does show that even when conditions are compromised, that the situation can improve. So our collective actions can therefore have a positive influence on the health of the watershed today and into the future. A large part of maintaining and improving conditions is working with stakeholders throughout the watershed. So that's why we're reaching out, to understand what is important to you and how you see us working together. As mentioned, one important way that CVC, our municipal partners, residents, and environmental organizations can continue to help enhance the resilience that we already see is through restoration and other conservation actions. Here you see completed conservation actions across the watershed up until 2020. This includes individual tree plantings, reforestation projects, wetland creation, implementation of low-impact development, and implementation of best management practices on agricultural lands. This summary of completed projects shows just how busy we've all been to improve conditions throughout the watershed. It is this cumulative impact of these actions that are ultimately required to build a truly resilient landscape. And it is the Watershed Plan that will create a blueprint for the actions to come. It will ensure that our efforts are strategic and give us the best bang for the buck, all while ensuring that we prioritize based on the best available information and all these products that have been pulled together into one comprehensive document. So before I wrap up, I wanted to discuss our next steps. As mentioned, the characterization report will be ready to share in the new year. Because the report is technical, we're repacking these stories into user-friendly formats that will be posted online on our webpage and other similar platforms such as the Story Map interface. If you haven't already, you should check our webpage out. This is also where you will find a link to an explainer video that provides an overview of the Watershed Plan. We're also releasing some of these results in short newsletters that touch on the key stories. If you're interested in receiving these and other Watershed Plan news, you can subscribe to the updates on the webpage. As mentioned, the scenario modeling and impact assessment is underway. We have a team of modelers, engineers, and analysts looking at how land use and climate change will affect things like components of water resources and natural hazards such as water balance, erosion, contaminant loadings, and flooding frequencies. We also have teams that are looking at changes in biodiversity, ecosystem goods and services, as well as the future availability of green spaces. In Phase 3, the Watershed Plan will be based on information from Phases 1 and 2, as well as consultation with municipalities and watershed stakeholders like you. This is where your input will be incorporated. Based on the information you share with us, we can identify which issues are of the highest priority and what solutions and conservation actions we can work with the public on to improve conditions. As mentioned, it is our collective action that will make a difference. This plan provides the information and guidance that all our partners can use to address the many challenges I discussed today. So stay tuned. Now that you've seen this presentation, I hope that you have a better understanding of what a conservation authority is and what types of work we do, as well as the process used to develop a watershed plan and some key results from the first phase of our work. We appreciate your interest in the project and value your input. The input you provide throughout the project help us determine if there are gaps we need to fill, but will also be incorporated in the development of the final watershed plan and implementation report. Feel free to reach out if you have any questions. Thank you.